All right, here we go. Finding angles, section 1.2. Please make sure to label your notes with the lesson number 1.2 or the title, which should be finding angles, and then today's date. So label every set of notes in that way. Get in that habit. Here's some of the things that we're going to do today. We're going to learn the notation to show measurement of angles and segments. We're going to learn the symbols for marking figures, the idea of congruence. What does congruence mean? And equal angles or congruent angles. We're going to learn about that as well. All right, see if I can move on here. Okay, so anything I have highlighted is a vocabulary word. Please make sure to have that in your notes. You do not have to do this word for word. Please don't do it word for word. It'll take you too long. So first we have an angle. An angle is formed from two rays, and they share a common endpoint. So all we mean by ray is a ray has one endpoint and continues on in one direction. Remember, a line continues on in both directions. A ray continues on in one direction. So we have two rays that have this common endpoint, in this case A. All right, so there's your angle. The common endpoint is called the vertex. There's your next vocab word. So the endpoint where the two rays meet is your vertex. And the two rays are called the sides of the angle. So three words: angle, vertex, side. All right? Two ways we could name this angle. We could say angle TAP or PAT. But notice, so I would say angle TAP, get used to the notation, or angle PAT. Notice that every time, or no matter how I name the angle, what's in the middle? The vertex is in the middle. So when I name an angle, you need to have that vertex in the middle of that angle. Okay, so we could say vertex A, or we could call it angle A. All right, moving on. So we might not name all of the angles, but let's at least name a couple of them. So if I look at this first figure right here, and I want to name some of the angles in there. Remember, the vertex has to be in the middle. So what if I use this as a vertex? We could say angle R, U would be in the middle because it's the vertex, and V. And again, I can go the other way and say angle V, U, R. I'm not going to name them both ways every time. Just know that the vertex is in the middle. So let's choose a different one. Oh, actually, you know what? Let's stick with that one for a second. Now notice there's a 1 in the middle here. So I could save myself a little bit of time if that's noted with a number. You could also just say angle 1. That's the other way to name that. So let's choose another one. Let's say this is the vertex. Right? If that's the vertex, here are your sides, or your rays that make the sides, and I would call that angle U, T, V, or the other way around, V, T, U. Again, vertex in the middle, right? All right, let's say this is a vertex, and I want to name the larger angle in this figure. So I notice that here are two rays, and that looks larger than either of the others that I could name. Here's my vertex, so I'm going to say angle X, A, Z. Or I could go backwards and say Z, A, X. Now if I want to name another one, not the larger angle, but maybe this one, I'm still going to use A as the vertex. And I could say then what? Angle Y, A, Z. Right? Again, vertex named in the middle of your angle. Another tip here when you're taking notes, if there is a drawing, copy down that drawing and label the parts if the parts are labeled. So this is geometry. We're going to be seeing a lot of figures in geometry. Draw those figures in your notes so that you have something to look back at. Again, we have a lot of vocab here at the beginning. So the measure of an angle is the smallest amount of rotation around the vertex. Smallest amount of rotation around the vertex. In other words, if my vertex is P, here's when I say the measure of an angle, I'm talking about that part, right? That's smaller than this part. So if I just say, what's the measure of angle P? I'm looking at the angle that's in red, the smaller angle. The angle that's in blue is called the reflex angle. Okay, so blue, the larger piece of that angle is the reflex angle. Now notice, when I have the smaller piece and the larger piece, or the angle and the reflex angle, what do they add up to? It's a full circle. So if this part is 136, that inside part, I should do that in red. So if that inside part is 136, that larger angle then should be 224, because 136 degrees plus 224 degrees is going to give me 360 degrees, which is the full circle. And so a reflex angle and the other angle that makes up that whole circle should add up to 360 degrees. All right, quick one here, and then we're going to practice some measurements. So I want you to have your protractor, please, with you so you can follow along and actually try to measure some angles. So we want to place that protractor right on the vertex of that angle. So see where the protractor goes? I'm lining up this middle of the bottom of your protractor, that T, with the vertex. Okay? Notice that this red line, or one of the rays, is on 0. 0 is that inside track. One of the rays is on 0. So when I'm measuring that, I'm looking at this inside track. And that inside track looks to me like it's somewhere between 30 and 40. So we might estimate that at about, in our case here, about 34 degrees. Now notice right here, even if I'm looking at the outside track, if this is 30, so look at the 150. If that's 30, then this would be 31, 32, 33, and 34. So that's where I get my 34 degrees. So you can read the smaller lines to get your 4 from the 30. All right, so let's practice this a little bit. Again, please have your protractor with you. I have a protractor here. So go ahead and draw an angle. Let's do this one. So go ahead and draw an angle this one looks to be a little bit more than a 90-degree angle, a little bit more than a corner. So just draw an angle on your paper that looks like it's just a little off of 90 degrees. Okay? And let's measure that. Let's see what it actually is. Is it 90 degrees? Is it more or less than 90 degrees? So remember what we said before. So I'm actually going to make this, make this a little smaller if I can. No, it's not going to let me. All right, that's okay. So I'm going to measure, I'm going to put that T down at the bottom of there. I'm going to line that up right at my vertex. So now that T, or the bottom of that, is at my vertex, right? I think first what I want to do is turn that. All right, now I can turn it. Okay, so lining that. This always takes me a minute. I'm going to line that ray up. Right, not quite lined up yet. There we go. I'll line that ray up with the bottom. Well, can I measure anything? This ray is coming out the other direction, right? It's not on my protractor, so I haven't set it up right. So let's try doing this another way. What if I take that and I line it up right there? So now I've lined up one of my rays. Your vertex is right here, right? Line up the vertex on the T. And I'm going to read, notice the 0 is on the inside track, right here. So I want to read the inside track. So I'm going to follow that other ray down. Okay, so I'm going to follow that ray down. I'm going to read the inside track right here. It looks like it's a little bit more than 90. So if I start at 90 and go 91 and 92, it looks like that's about 92 degrees. So a little bit more than a right angle. All right, so let's try another one. Again, let's line this up. So I'm going to turn this around here. Okay. I'm going to line that up. Again, line that little T, or the center of the bottom of your protractor, on one of your rays. 0, again, is on the inside track right here. So I want to read the inside track. Here's my other ray. So where is that? It's between 10 and 20. Now if I follow my smaller marks, looks like that would be, if this is 10, this is 11, 12, 13, 14, 15, and 16. So it looks like that is 16 degrees. right? So it's going to take some practice with the protractors, but we'll get there. All right, it's kind of a long lesson, so just bear with me here. So it's possible to move one angle to fit over another angle. If that's possible, if you can fit one over or put one angle right over on top of the other angle, those angles are called congruent. Okay, fit one right on top of the other, those angles are congruent. They're congruent if they have equal measures. So if you have two 16-degree angles, those are congruent. So equal measures are the same number of degrees. And we can see that if you look at these two, we have this hash mark. This one also has one hash mark. If the angles are marked in the same way, that means they're congruent. Okay? So right here, what this means is angle DOG is congruent to angle CAT. So this means congruent, or the same as. Right? So if I'm saying one angle is the same as the other angle, I'm going to mark it in that way. The only difference, whoops, didn't mean to erase that highlighting. So this one, notice, is a little bit different. This means the measure, and means the measure. The measure of angle DOG equals the measure of angle COT. Notice that when I'm talking about the measure of something, I use an equal sign instead of a congruent sign. Okay, so if I'm talking about something just is the same as something else, you can set it on top of the other one, I'm going to use congruent. But if you're talking about the measure of something, so you've actually gone and you've measured it, one is 16 degrees, the other one is 16 degrees, I'm actually going to use an equal sign. Okay, so congruent if they're just the same as, equals if you're talking about the measure of something. They have exactly the same angle measurements. And I know that's a little vague, but we'll get used to it again. Okay, so let's look at another example. I think there's just one more after this. We got to look now at angle bisectors and congruent angles. Okay, well, I'm going to go back a slide because I missed something. I missed this last example down here. So when I say an angle bisector, what I'm saying is I have a ray that goes right through the center of that angle and cuts it into two equal pieces. And I know that it cuts it into two equal pieces because it's marked with those hash marks. One hash mark here and one hash mark here. That means that those angles are congruent, or they have the same measure. And it also means that ray CD is an angle bisector. Okay, so ray CD is an angle bisector of angle BCA or ACB. Okay, so you can see that whole thing right here. Ray CD bisects angle ACB so that angle ACD, or this angle, is congruent to angle BCD, or this angle. All right, so let's do at least a little bit of this. Let's name each angle bisector and the angle that it bisects. So if I look at this first one, is this ray right here a bisector? If I look at these two angles, if that's a bisector, then those should be congruent. But I have 43 and 44. Those are not congruent. So that is not an angle bisector. Now I can see with the second one, 52 and 52, it cuts it into two equal pieces. So I would say that ray RP bisects angle SRQ. So ray RP bisects angle SRQ because it cuts it into two equal pieces. If I wanted to note that, I would just do this. All right? So let's look at this one right here. This one's a little bit different, this next one. And I'm going to skip part B. We're not going to name all the congruent angles. For now, we're just going to focus on the bisectors. For that second part anyway, for that second figure. But if we move over to the third figure, does anything bisect anything else? It doesn't look like there's a bisector here, so let's see if we can find anything that's congruent. We could say, because these are marked in this way, we're going to say that angle YMN is congruent to angle EMO. Make sure you're using the right letters. Vertex again in the middle. Here's another question. Can you see another set of equal angles here? What do I say, or does it make sense to say that angle YMO is congruent to, so I'm saying this one, YMO. What could I say that's congruent to? Well, couldn't I say it's congruent to EMN? Right? If these two pieces are congruent, and I'm adding this middle piece to each one, really I'm adding the same amount to each one. So I could say that YMO is congruent to angle EMN. So there's another congruence. All right, almost done. Point D is in the interior of CAB. So we have something right here, this point that's inside of the angle. The ray is also inside of that angle. Then the measure of, remember M means measure, the measure of CAD plus the measure of DAB. So I'm going to draw that out. What I'm saying is the measure of this angle. It's going to make sense when you see it. Plus the measure of this angle, right? The blue angle plus the red angle is going to give me the whole entire angle, right? So the measure of CAD plus the measure of DAB is equal to the measure of CAB, equal to the whole thing. I'm just taking two pieces, in this next example, two pieces of pizza and putting them together. So you have a slice of pizza with a central angle that measures 140 degrees. So we're going to see if we can do this here. So this right here, maybe not. Let's do green. Okay, so that interior angle is 140 degrees. If I want to split that piece of pizza and we cut it through, let's say we're trying to cut it through the middle, but it doesn't quite turn out to be the middle. You see that you cut it and one slice measures 60 degrees. So I'm going to cut that the best I can down the middle. But this angle ends up being 60 degrees. Well, if that angle is 60 degrees, what's this angle going to be? We can set up a very simple equation to solve that. So it looks like 60 degrees plus something degrees is going to give me 140 degrees. So 60 plus what is 140? I could say subtract 60 from both sides, or I could just say, well, I know that 60 plus 80 is 140, so that other slice is 80 degrees in an interior angle.